Welcome to the third lesson in Session 6 on solving quadratic equations by completing the square. A quadratic equation is any equation that can be written in the form a times x to the second plus b times x plus c equal to 0, where a represents the coefficient of the quadratic term, b represents the coefficient of the linear term, and c represents the constant. We will learn four methods for solving a quadratic equation. The first method is to solve by taking the square root. Solving by taking the square root only works when b is equal to 0. The second method is to solve using the zero product property. Zero product property is a great way to solve through factoring, but it only works when the equation is factorable. The third method is to solve by completing the square. Now it will work for any and all quadratic equations, but is most convenient to use when a is equal to 1 and b is even. The last method is to solve using the quadratic formula. Similar to completing the square, it also works for any and all quadratic formulas. I usually recommend this method when the other three methods are unavailable or inconvenient. In this lesson, we're going to learn how to solve a quadratic equation by completing the square. To complete the square, we need to algebraically manipulate the equation to create a perfect square trinomial. Doing this will allow us to factor and solve by taking the square root. In our first equation, we have x to the second power plus 6x minus 15 equal to 0. The first step in solving by completing the square is to make sure a is equal to 1 and move the value of c over to the right side of the equation. In our first equation, a is already equal to 1. So the only task I have to accomplish in completing step 1 is to add 15 to both sides. Notice how I've left a blank space on both sides of the equation. We're going to add a number to both sides of the equation to fill in those blanks, but we need to add a specific number that's going to create a perfect square trinomial on the left side of that equation. Now to create a perfect square trinomial, we have to add half of b, so we take b, divide it by 2, and then we raise it to the second power. So for the given equation, the value of 6 is equal to b. Dividing it by 2 and raising it to the second power gives us 9. So we add 9 to both sides of the equation. From this point, we've created a perfect square trinomial on the left side of the equation, and now we're ready to factor. Factoring the left gives us the quantity of x plus 3 squared equal to 24. At this point, we're ready to take the square root of both sides. Taking the square root of both sides gives us x plus 3, and simplifying the radical on the right leaves us with plus or minus 2 root 6. The last step is to isolate the variable. So to isolate the variable in this equation, my last step is going to be to subtract 3 to both sides. This is going to give me my answer of negative 3 plus or minus 2 root 6. Now notice, the equation is irrational. We expect irrational and complex solutions when completing the square. If the equation yields rational solutions, that tells us that the equation could have been factored. While completing the square is best used when a is equal to 1 and b is even, it's a method that will work for every quadratic equation, including when we have rational solutions, when b is odd, and when a is not equal to 1. So here's our three examples. In the first equation, x to the second power plus 10x equals 24, this is ideal for completing the square. Your value of a is equal to 1, the value of b is even, and your constant term is already on the right side of the equation. So we just have to identify what magic number we're going to add to both sides to complete the square. Taking the coefficient of our linear term, the value of b is 10, dividing it by 2 and raising it to the second power gives us 25. Factoring the left side of the equation while simplifying the right leaves us with the quantity of x plus 5 squared equals 49. Now at this point, notice the right side of the equation is a perfect square. When we take the square root of both sides, that leaves us with the x plus 5 equal to plus and minus 7. Remember, anytime we solve an equation by taking the square root, we have to leave a plus and minus sign. Subtracting 5 to both sides is going to leave us our answer. 7 minus 5 is 2, Negative 7 minus 5 is negative 12. Now in the next example, we have a value of b that is odd. A is equal to 1, so we're okay there. We have to move the value of 8. The value of c needs to be subtracted over to the right side of the equation. So we start by subtracting 8. Now the value of b is odd. So we take it, do the same thing, we divide it by 2, which is 5 over 2, and then we raise it to the second power, which gives us 25 over 4. So we add 25 over 4 to both sides of the equation. Now the left side is still, it creates a perfect square trinomial, and factoring gives us the quantity of x plus 5 over 2 squared. Simplifying the right side of the equation, taking negative 8 and adding 25 over 4 gives us negative 7 over 4. Taking the square root of both sides gives us x plus 5 over 2 equal to plus or minus I root 7 over 2. And then subtracting 5 over 2 from both sides gives us our answer of negative 5 over 2 plus or minus I root 7 over 2. So as you can see, the value of b being an odd number introduces fractions on a few different levels, and that's going to increase the complexity of solving the equation, which is very difficult for algebra learners. That's even more true over here on our last equation where the value of a is equal to 2. So our first step is to divide the entire equation by 2. That gives us x squared minus 8x equals negative 5 over 2. We need to identify what value we're going to add to both sides. So we take negative 8 and cut it in half and raise it to the second power, and that gives us 16. At this point again, we're ready to factor. X minus 4 quantity squared is equal to 27 over 2. When we take the square root of both sides, that gives us x minus 4 equals plus or minus 3 root 6 over 2. Last step is to isolate the variable. Gives us x equals 4 plus or minus 3 root 6 over 2, and that's our answer. So as you can see, completing the square is a nice, clean method to use when the value of a is equal to 1 and b is even. If b is odd or a is not equal to 1, you're going to have to work with a bunch of fractions on a handful of different levels. So, to complete this lesson, you need to successfully complete the quiz. Good luck!